Good day, everyone. So my name is Merveille Sifa Bamporiki. I am a student for the Advanced Diploma on the TPG 3700 module at the University of South Africa. So I chose the HOOF road to be upgraded. It is located in the Eastern Cape, South Africa. So about that road. So the HOOF road is an existing gravel road which link the R340 to the national tour, passing by an agglomeration constituted of residential houses, schools, shopping centers, and as well as farms and touristical destination. So we decided to upgrade this route, particularly because it is destined to carry more traffic as there is a new development that is being built and it will need those road services. This will allow for faster and more comfortable trip and avoid accidents of cars. So previously this road was a two-lane road. Now we are upgrading it to become a four-lane divided road. So we upgrade both the geometrical part with the cross-sectional section being now four-lane, as well as the pavement side, because we are going to apply a bituminous surfacing on this road to be, more comfortable for the users. Now, how do we plan this whole work of road construction? First of all, we start with the preliminary work, which is done on site, and then we do the design work, which is done mostly at the office, and then the execution, which is the actual construction of the road. What is the preliminary work? So the preliminary work on the road project consists of getting the necessary information in order to conduct the work efficiently. So by there we see the site investigation, the DCP test, the soil sample collection, the surveying, and also the environmental studies, because if we want to upgrade, if we want to improve, we need to have the existing situation so that we can efficiently do the design. We can efficiently propose, where the work will pass, all the alignments, economical alignments, so that we don't spend too much on cuts or fill. And yeah, so we need to know the existing situation. We need to know where the there is water course. We need to know where we can place our culvert, and we need to know where there is an agglomeration of people or farms, so that environmentally we don't touch what has to be prevented from construction. Yeah, this is some images of how the preliminary work should be. Like we can see, the first one is the survey work, where we get all our elevation, all our data. We collect the sample, the data with the station, the survey station. And the second image is the DCP test. We see someone on the axis of the project road, doing the DCP test to get the CBR, which is the California bearing ratio. And the third is the sieve analysis, where we see the different type of road material that we could find in our project. Now the design work. Here the design work can be divided into three: the geometric design, the pavement design, and the drainage design. So what is the geometric design? The geometric design is the establishment of a travel lane configuration, alignment, location, and all dimensions related to the highway cross-section. So here we see the horizontal alignment. The horizontal alignment is what you see from the top view, the curvature, and all that you see from the top view, the curvature or even the super elevation, all that is part of the horizontal design that we have to do in the office. Also, we have the vertical alignment. this is what you see when you're standing on the road, you know, all the topography of the road, if there is like a valley or a mountain, what you see. So that's the vertical alignment. That's also where we get our cut and our feel, to make the road very comfortable. And thirdly, we have the cross-sectional element. We have the cross-sectional element where we design for, we provide for the drainage, we provide all the road reserves. So the drainage, the where pedestrians will walk, and all the elements of the work. Those are part of the geometric design. One of the tools that helped us uh, efficiently do the geometric design is Civil 3D, which is a design software that we use to do the horizontal and vertical alignment as well as the cross-sectional design based on the survey data collected on site. So the element of the horizontal and vertical design are the survey data, of course, the design speed, the traffic, and also the function of the project road. So here an example of how the Civil 3D software looks like. Um, yeah, this is also part of the Civil 3D, and this is an example of a vertical alignment where you can see the software based on the data that we input. It gives us, all the elevations. We can see down the stake values, at what stake values we have this height, and then we can have a natural ground line. In the legend, we can read the natural ground line. We can also read the project road line. So we know, what quantity of material that has to be extracted or what quantity of material has to be added. Now, second of all, we have the pavement design. So the pavement design here is everything that is dealt with the layers of a road, because we have different layers. We have the subgrade, we have the sub base, we have the base, and we have the surfacing. So based on elements such as the climate, elements such as the CBR, which is the California bearing ratio, elements such as the traffic road, we are able to actually, size all these layers so that we can have a very, comfortable road. And we use the catalog design that we get in the TRH4, which is, I would say, an empirical method, based on experience of, other engineers that made this documentation for us to work efficiently. Here we could see that from the TRH4 that I previously mentioned, they provide categories of materials and the thickness for the different CBR ratio that could be found in the project role after the surveying. And on the right hand side, we can also see the classification of the traffic based on the counting that we will also do on the preliminary work. And here is the selection. This is the catalog. This is the selection of the pavement, based on the traffic on top, the ES1 and so on, based on the traffic and based on the category of the road. So whether it's a class A, class B road, and we select the type of, layers that we're going to use. For our case, in our project for the HOOF road, we had two options selected. We have the one with the seal, the double seal surfacing, with a base of 150 G2 and 150 C2 and G5. So we therefore selected the granular base road with surfacing seal, and the 150 G2 and the 100 and 200 G5, because it's cheaper than using the cemented base as the granular can be found easily. And then third and last, we have the road construction, which is where everything comes together, where we actually having the result of our design in the office. We at the road construction, we use all our plans. We use all our plans to actually build the road with the exact size of the layers, with all the thicknesses, after approval of the engineer in charge. Thank you so much for your attention and have a great day.